This is the map of the world. The surface covered by land is shown in grey, while parts of the ocean are covered in blue. On the former, volcanoes are not strange concepts, and you hear names like Pinatubo, St. Helena, Pompeii, and so forth, and the destruction they cause, including the loss of human lives. However, many people find the idea of volcanoes underwater strange and unbelievable, even though they are also very dangerous. In this video, we take you to the sites of the largest underwater volcanoes exploding and cracking open the earth in all their violent glory. Volcanoes are some of the most spectacular events in nature. They cause massive eruptions that not only cause untold destruction, but also literally change the world around you and alter the political, social, and economic landscapes. Many great cities have been made desolate by these awe-inspiring natural phenomena. Volcanic eruptions are complex, as volcanologists will tell you. They are very diverse because they can be caused by a multitude of events. While you go about your business daily, directly under your feet, under the Earth's crust, there are layers of molten rock which, because of the high temperatures at the core, are melted to form magma. Magma is made up of different gases, mainly carbon dioxide, water vapor, and sulfur dioxide. Nature stores in magma chambers that are sealed beneath a lid of solid rock. However, the problem is the storage compartment is not fail-safe. Because magma exists in the gaseous form, it is less dense than the rock above it and begins to rise. At the same time, water vapor escapes as bubbles, which increases the relative density of carbon dioxide and sulfur dioxide. Our volatile magma will eventually expand to 1,000 times its original size. At this volume, the pressure on the chamber lid increases to such an extent that we just can't avoid or postpone an eruption. Imagine shaking your soft drink and it exploding when you pop open the lid. In this case, by shaking it, you're separating carbon dioxide molecules, causing a buildup of gas and pressure, which escapes violently when the lid is cracked open. This is what a volcanic eruption looks like, but on a far more powerful and destructive scale. When our magma is released through the ruptures in Earth's crust we call volcanoes, it is known as lava. This can be super hot and you don't want to go near it, as much as 1100 degrees Celsius. Normally, it will also form what is called pyroclastic clouds. These are cascades of hot ash, gas, and molten rock fragments. They can get as hot as 1000 degrees Celsius and shoot around at 700 kilometers per hour. Volcanic eruptions come in different sizes, so what determines how large a volcanic eruption is? The size depends on factors like how thick the magma is, the density of gases it contains, and the amount of new magma forced into the magma chamber. Basaltic lava allows gas to escape easily, resulting in smaller eruptions, while andesitic and rhyolitic lava makes it harder for the gas to escape, leading to larger eruptions. But what causes a volcanic eruption to occur? This is where it gets interesting and dangerous. The main idea is that an increase in pressure on the chamber lid causes the magma to be released from beneath it. However, there are different reasons behind the eventual movement of magma and the type of eruption that results. Volcanoes are usually found near the boundaries of Earth's tectonic plates. Sometimes the plates are spread apart, leaving a yawning gap on the surface, or they push underneath one another. This is known as subduction. When the plates separate, our magma rises slowly in order to fill the gap through a gentle explosion of thin basaltic lava. But things get violent if one plate pushes underneath the other, forcing molten rock, sediment, and seawater down into the magma chamber. The rock and sediment melted into fresh magma and eventually overfill the chamber until you have an eruption that releases sticky and thick andesitic lava. But plate tectonics is, however, not the only cause of eruptions. Decreasing temperatures can cause old magma to crystallize and sink to the bottom of the chamber, forcing fresh, liquefied magma up and out, similar to what happens when a brick is dropped into a bucket of water. A decrease in external pressure on the magma chamber may also allow for an eruption by minimizing its ability to hold back increasing pressures from the inside. This is often caused by natural events, such as typhoons that decrease the rock density, or by glacial melting on top of the chamber lid, which alters molten rock composition. This means a volcanic eruption can be triggered by another natural phenomenon akin to waking a sleeping giant. So-called hotspot volcanoes are the ones that form away from tectonic plate boundaries. These are created when plates move and expose hot uprisings from Earth's mantle, known as plumes. However, what happens when a volcano is located underwater? Interestingly, there are more volcanoes underwater than on the surface of the Earth. In fact, most of the world's volcanoes are located in the middle of the ocean in a mountainous chain that runs around the planet and covers a length of over 30,000 miles. These massive volcanoes can reach heights of over 18,000 feet. Underwater volcanoes are interesting because of their consequences. For example, if you love your Hawaiian vacation, you have an underwater volcano to thank for it because the islands were products of an underwater volcano. They solidified lava that effused from a volcano beneath the ocean from an underwater or submarine volcano. However, because they happen underwater, these volcanoes are not easy to be recorded while happening. Most of them end up not even boiling the water. But scientists can study them and their effects by examining samples of the debris that they produce. They can also piece together their size and the level of their impact. However, when scientists manage to capture an underwater volcano, it's just as stunning as terrestrial, like the Tonga eruption. It was captured as it happened using an Earth-watching satellite, and it showed how explosive things could get in the South Pacific. It also allowed scientists to follow the progress of the eruption as they had never done before. The volcano eruption on the island of Hunga was captured by the U.S. National Oceanic and Atmospheric Administration, NOAA. The video of the eruption shows a vast plume from the volcano rising high into the atmosphere like a giant mushroom during the eruption as a shockwave extends outward from Hunga, one of the 170 islands that makes up the South Pacific Kingdom of Tonga. The Hunga underwater volcanic eruption birthed a 4-foot tsunami that struck Tonga's capital of Nuku'alofa at a distance of about 40 miles or 65 kilometers south of the volcano. A sonic boom from the eruption was heard across the Pacific Ocean, reaching as far away as Alaska. The city of Nuku'alofa was covered in a thick film of volcanic dust, and the Tonga capital city suffered a loss of its internet infrastructure. There was an eruption about a month before, but the second one was about 7 times more massive. However, the eruption occurred in stages. According to observations of satellite images, there was little eruptive activity between the 1st and 2nd of January. On January 2nd, the area west of the volcano had green-yellow discolored water, accompanied by white gas and steam emissions drifting northeast on the southwest end of the westernmost island. The volcano was already increasing the surface area of the island as it had added about 1.6 kilometers squared. Real estate developers will love that one. The next day, Hunga volcano produced a small ash plume rising about 7 kilometers. Just what happened after that was not known because the site witnessed a cyclone which obscured the satellite's view of the eruption. However, days later, the satellite again picked up a minor plume. By this time, some pumice had washed up to the northwestern beaches. Beachgoers in Nuku'alofa reported a sulfurous odor. Things began to get intense in the middle of January. A subaerial generated a mushroom-shaped eruption plume consisting of gas, steam, and ash. The mushroom was 5 kilometers wide at the base and rose to the stratosphere, an 18 to 20 kilometer altitude. The plume expanded radially to about 260 kilometers in diameter, extending over the city of Tongatapu, located 70 kilometers to the south, Eo at 106 kilometers, Ha'apai 130 kilometers away, and Vavau 270 kilometers distant. Separately, geologists using a boat observed Sirtzian pulses ejecting dark, dense material into the air and pyroclastic flows expanding over the ocean. The activity reversed the gain in land surface area, with approximately the middle third of the island disappearing. Sorry to the ambitious real estate developers that celebrated too early. The land loss was confirmed by Planet Labs using satellites. At this stage, the authorities had to issue a national tsunami warning due to the abnormal swirling water off the coast of Nuku'alofa. The eruption lasted more than 12 hours, producing a plume that grew to 20 kilometers. Places as far as 75 kilometers away reported ashfall. The plume contained a strong amount of sulfur dioxide, leading to people reporting the smell of sulfur in places like Tongatapu and Ha'apai. As a safety measure, all domestic flights in Tonga were cancelled the next day. Astonishingly, the Global Lightning Detection Network (GLD360) ground-based network detected 191,309 lightning events within a 48-hour period, or up to 30,000 per hour. Meanwhile, Hunga was not done erupting. A larger submarine eruption began on January 15 from vents just below the surface of the ocean, generating an eruption plume of gas, steam, and some ash. It generated a plume rising to 15.2 kilometers, with the top spreading at least 600 kilometers in diameter. According to news reports and social media posts, residents in Nuku'alofa heard multiple loud booms and saw a large expanding eruption plume that eventually covered all the Tongan islands. This eruption lasted about 8 minutes. There was another ashfall which deposited materials several centimeters, with the rain of ash lasting about 10 hours. This affected water tanks, and some residents reported having difficulty breathing the ash in the air. This round of eruption also caused a communications blackout across the country, with damages to the underwater fiber optic cable providing access to the internet reported. The ash also damaged satellite terminals. Eruptions and lightnings go hand in hand, and this round produced 400,000 lightning events. The plume would eventually top 20 kilometers in height, with data from other satellites suggesting it rose to 30 kilometers. For the rest of the month, there was no new eruption at Hunga Tonga Hunga Hapai, and satellite imagery showed that most of the previously combined island had been destroyed, leaving only a small part of the island of Hunga Tonga and the southwest island of Hunga Hapai visible above the ocean surface. Pumice rafts were visible to the southeast of Hunga Hapai. In all, Hunga Tonga Hunga Hapai volcanic eruption killed 3 people, but more were injured in the tsunami. Damages included buildings and whole villages washed away or otherwise damaged. The roofs were covered in ash and trees were uprooted. However, 2 deaths were also reported on a beach in Peru. All the houses on Mango Island were destroyed in the tsunami waves. In Fonoafua, only 2 houses remained standing. Another underwater volcano that produced new land was the one reported near the French island of Mayotte. Within the space of 6 months, a giant edifice measuring 800 meters in height and 5 kilometers across was born. The changes were stark when scientists put side-by-side before and after maps of the area. This was revealed by Marc Chaussedon, the director of the Institute of Geophysics in Paris IPGP. His team, along with scientists from the French National Research Agency CNRS and other institutes, had witnessed the birth of a mysterious submarine volcano, which, according to them, was the largest such underwater event ever witnessed. There are about 250,000 people living in Mayotte, and they reported small earthquakes daily, the beginning of a series of events. While people sought information and assurance, the authorities were not much more informed. This was because even though Mayotte has a seismometer, triangulating the source of the rumblings needed several instruments, and the nearest to others several hundred kilometers away in Madagascar and Kenya. However, a serious campaign to understand what was going on in the ocean started later, with a team of scientists led by Nathalie Fouet dropping 6 seismometers on the ocean bottom 3.5 kilometers down, close to the activity. When the scientists examined data from the seismometers, they discovered a tightly clustered region of earthquake activity, ranging from 20 to 50 kilometers deep in the Earth's crust. The team theorized that a deep magma chamber fed molten rock to the sea floor and then contracted, driving the cracking and creaking of the surrounding crust. A volcanic tremor originating near Mayotte was recorded across the globe. These kinds of tremors are different from short, abrupt earthquakes. They're also known as harmonic tremors and produce a prolonged release of energy caused by magma moving underground. The tremor suggested that magma was flowing somewhere near the islands, which was notable because the seismic waves were even lower frequency than your average tremor. In fact, scientists almost missed the 25-minute tremor because it was so low frequency and slow. GPS measurements obtained on Mayotte also suggest a shrinking magma chamber. The island sank by 13 centimeters and moved 10 centimeters east. According to the map of the seafloor, the volcano shot an estimated 5 cubic kilometers of magma onto the seafloor. The scientific equipment also detected plumes of bubble-rich water rising from the center and flanks of the volcano. Fishermen reported shoals of dead fish, but this could not be confirmed. However, the team collected water samples from the plumes that could be studied for clues about the composition of the magma, the depth from which it came, and if there is a risk of an explosive eruption. Other samples that the crew got included rocks from the new volcano, which were reportedly popping as they were transported because of the high-pressure gas trapped inside them. Other scientists analyzed seismic wave data collected by the network of seismometers, including those installed on land and on the sea floor. The network logged some 17,000 events, 94% of which occurred on the western portion of the Mayotte Ridge and 25 to 50 kilometers below the surface. 84 more earthquakes lasting 15 seconds and classified as very low frequency were also reported. The very low frequency earthquakes probably came from a seismic source that was repeatedly excited, possibly faults destabilized by magma in a large, deep reservoir. To have so many earthquakes deep in Earth's interior is unusual. Many seismic events caused by volcanic activity occur above the moho, which is the boundary between the crust and mantle, about 17 kilometers below the surface of Mayotte. The researchers took the deep earthquakes as evidence of geodynamic activity in the upper mantle and lower crust. Magma from the upper mantle likely filled a reservoir and pressurized the region. As the magma traveled through the crust and eventually to the sea floor, it would have instigated swarms of deep earthquakes. What effects do underwater volcanoes have on marine life? Scientists have made an interesting discovery about animal life in the water surrounding active non-terrestrial volcanoes. The scientists were studying the water around the Kavachi volcano, which are located near the Solomon Islands. They were shocked to find a school of sharks in the area. They included reef sharks, hammerheads, and scalloped hammerheads. Kavachi volcano is active and often erupts, but the sharks are not scared off by the underwater explosions or submarine boiling lava, but actually thrive here. How do they cope in this environment? Scientists postulate that the sharks have special pores near their snouts called ampullae of Lorenzini, which reportedly allow them to sense changes in Earth's magnetic field. The sharks use this information for homing and migration, and may also use them to avoid dangerous situations. Of course, they do not stay nearby during eruptions to avoid getting cooked alive. Studies have shown that the sharks can detect approaching hurricanes and cyclones, so they may be able to know when something bad is about to happen and rapidly move out of the way. However, what puzzles scientists is what draws these sharks to these potentially dangerous environments. Suggestions include they hang around the volcano for reproduction or simply looking for food. Kavachi turned out not to be the only place with active underwater volcanoes that attract sharks. Scientists also visited another location in Piton de la Fournaise, off of France's Union Island in the Indian Ocean. In fact, the island's government had to ban swimming and surfing after more than 20 shark attacks. However, scientists have yet to find a satisfactory explanation for the presence of sharks in the sites of underwater volcanoes. Perhaps the most popular underwater volcano is Krakatoa, whose eruption literally changed the world. Krakatoa is an island near the Strait of Sunda, located between Java and Sumatra in Indonesia. It was a small uninhabited island, about 5 miles long and 3 miles wide. It had 2 elevations. The taller is the peak of Krakatoa, rising at 2,750 feet above the sea. On the adjacent land are volcanic cones, some active, some slumbering, and others dead. Krakatoa was active in 1680, with observers reporting a great storm and an earthquake at sea, along with booming thunders and cracklings. They also reported a strong sulfuric atmosphere and large quantities of pumice floating on the sea. For about 2 centuries after that, Krakatoa remained a gentle island with lush greenery that caught the eye of seafarers tired of seeing the same boring sea for weeks. However, things would change dramatically in 1883, starting with subterranean disturbances reported in Batavia, a city located 80 miles away. Interestingly, the inhabitants of the town Anja did not report anything unusual, even though it was only 25 miles away. Similarly, the inhabitants of Merak, about 35 miles from Anja, went about their businesses unaware of the terrifying events that would soon happen. The people of Batavia heard a booming noise, followed by a rattling of doors and windows on May 20th, and the trembling continued to the next day. In Sumatra, Teluk Betong and Semanggo towns experienced ashfalls, although they were light. While Krakatoa was suspected as the source of the ash, there were other volcanic sites that seemed more likely to be the culprit. By the next day, however, Krakatoa could no longer hide as smoke was seen rising from it. During the next 8 or 9 weeks, the eruption continued with increasing vigor, sending out masses of pumice and molten stone and increasing volumes of steam and smoke. Although the prevailing monsoon carried them westward, the greater part of the matter thrown out, a cloud of lighter particles rose higher, and encountering an easterly current of air, some of the dust fell on the island of Timor 1,200 miles away. The volcanic activity in Krakatoa stepped up on August 21st, so much that a ship reported it could not access the strait because of the massive shower of pumice and ashes. On the afternoon of the 26th, there were violent explosions at Krakatoa, which were heard as far as Batavia. High waves first retreated and then rolled up on both sides of the strait. The night would be a terror, with total darkness punctuated by electrical phenomena on a terrifying scale. The terror of the gigantic column of smoke and ashes was seen as far as Batava. Some of the debris made it to Cheribon 500 miles away. The morning of the 27th would bring an even more gigantic explosion, which people in the Andaman Islands and India heard. It also generated an immense tidal movement, resulting in a great loss of lives reported in the dailies. The ejected miles rose so high that when it spread itself out, it covered the whole western end of Java and the south of Sumatra for hundreds of square miles. Total darkness ensued, and abnormal atmospheric and magnetic displays were observed. Compass needles rotated violently, and the barometer rose and fell many tenths of an inch in a minute. Between 10 and 12 o'clock of that day, the subterranean powers burst their prison walls with a terrific detonation, which spread consternation and alarm among the dwellers within a circle whose diameter lay across nearly 3,000 miles. This was followed by deep darkness, with a heavy downpour of mud and debris. By the sunrise on the 28th, the darkness was starting to go away, allowing people to survey the extent of the damage caused by the volcanic eruption. It was realized that the entire northwestern part of Krakatoa Island had disappeared. The line of fracture began at a point south of Lang Island and formed an arc of a circle passing through the peak to the western side of the island. Before the eruption, Velatten and Lang Islands were covered in greenery, but in its place was scoria. However, even though a portion of Krakatoa was gone, a small island had appeared. Small necks of land had been thrown out from the eastern side of Velatten and the western point of Krakatoa. The effects of Krakatoa were felt around the world. For example, the undulations were registered in Mauritius, Seychelles, and South Africa, and on the shores of the Pacific Islands on the same day that Java villages were swept away. Also, Krakatoa's underwater volcano started off with an atmospheric wave that traveled around the world. The wave is easy to track to this day because different barographs located around the world took unusual records. For example, in St. Petersburg in Russia, unusually high atmospheric pressure were reported, followed by a drop immediately. It was the same at Valencia in Ireland, at Coimbra in Portugal. Shortly after, the rest of Europe recorded similar phenomena. However, the anomaly was more pronounced at the western observatories than at the eastern, but the general appearance of the curves at neighboring stations were not that different. In addition, globally, there were observations of magnificent sunlight effects, extended dawns, and lengthened twilights. In some places, the sun appeared perfectly green, and so continued for 48 hours, and that the moon and the stars gave a green light as well. Mariners reported peculiar red sunsets in the South Atlantic several weeks before the Java eruption. The effects also appeared on the east coast of Africa on the second day, on the Gold Coast on the third, at Trinidad on the 6th, and in Honolulu on the 9th day. Krakatoa has not been exactly silent since the eruption of 1883. In fact, since 1927, minor eruptions have been frequent and have constructed a new island, Anak Krakatau, which means child of Krakatau. By 1960, Anak Krakatau had grown to a minimum diameter of about 1 mile or 1.5 kilometers and a height of 545 feet or 166 meters. Let's hear what you think of underwater volcanoes in the comment section below.